Hello, and welcome to this presentation, Understanding Semi-Rigid Cables. In this presentation, we'll provide a short technical introduction to semi-rigid cables and how they're used in radio frequency applications. One of the greatest advantages of semi-rigid cables is their phase stability. So please see the separate presentation, Understanding Cable Phase Stability, if you're interested in learning more about this aspect of semi-rigid cables. As the name implies, a semi-rigid cable is more rigid than a conventional coaxial cable, in part because the outer sheath or shield is formed by a metal tube. Because of this, semi-rigid cables maintain their shape. They are bent or formed during manufacture, and generally cannot be reshaped after this initial bend. The ends of a semi-rigid cable are normally fitted with standard RF connectors, such as type N, SMA, etc. Semi-rigid cables offer significant advantages over traditional flexible coaxial cables, and this is particularly true when they're used in so-called challenging environments and applications. These cables are, however, more expensive and more difficult to both manufacture and to work with. Over the next few minutes, we'll go into more detail on the technical aspects and common applications of semi-rigid cables. Let's begin with a few of the advantages of semi-rigid cables. They support very high frequencies, up to tens of gigahertz, and even at higher frequencies, they have very low attenuation and insertion loss. They also have good VISWAR or return loss performance, in large part because the solid tube has fewer small discontinuities compared to the shield of flexible coax. The solid outer conductor provides very high shielding effectiveness or isolation, and this reduces the potential for EMI or EMC issues. Semi-rigid cables are resistant to both physical stresses, such as shocks or vibration, as well as to thermal or temperature changes. Being resistant to bending and changes in temperature gives these types of cables very good phase stability. And finally, semi-rigid cables can make turns and bends much more tightly than can be made using flexible coax, and thus semi-rigid cables are an excellent choice in tight or cramped environments. Semi-rigid cables are often used in challenging environments and applications, such as military, aerospace and defense, heavy industry, etc. They're also used in applications which require phase or phase length to be stable and tightly controlled. A good example of this is phased array radar. Semi-rigid cables are also commonly used in applications which require constant impedances, an example of which would be power transfer within magnetic resonance imaging systems. And as we mentioned previously, the outer shield of semi-rigid cables greatly enhances their electromagnetic immunity. Among other things, this makes semi-rigid cables a good choice in installations that are in close proximity to transmitters. Semi-rigid cables are also used in test and measurement applications, in particular for cables that are not moved or reconnected often, and/or when high performance is needed. A good example of this are the loops for bridging the direct receiver access ports of a VNA. Semi-rigid cables provide the very high signal quality, phase stability, and immunity to noise and interference that are needed when exposing these paths to the external environment. Similarly, RF conformance test systems may use semi-rigid cables to connect different instruments, switches, etc., since these setups are generally static and require the best possible conditions for transferring RF signals between devices. Next, let's take a closer look at the construction of a semi-rigid cable. As we've mentioned, the outer conductor or shield is a solid tube, usually made of aluminum, tin-plated copper, or stainless steel. Within this is the dielectric insulating material, which is almost always some type of PTFE, or polytetrafluoroethylene. And the center conductor is normally either silver-plated copper or silver-plated copper weld. Recall that in most cases, cables are made into assemblies by connectorizing them with standard RF connectors, such as N, SMA, MMCX, etc. Manufacturing semi-rigid cable assemblies requires both special tools as well as special skills or techniques. The tools used to form the cables may be hand-operated, or they may be operated mechanically or programmatically. Note that semi-rigid cables are almost always manufactured on demand to a customer-provided specification, and that once they are manufactured, they generally cannot be adjusted or reshaped. Let's end with a brief summary. Semi-rigid cables differ from flexible cables in that they use a rigid metal tube as their outer shield, and this provides a number of advantages, including low loss and good viswar performance, good electromagnetic isolation or immunity, and very high phase stability. Much of this phase stability is related to the resistance to both mechanical and thermal stresses. Note too that semi-rigid cables are also easier to form into tight bends, or to fit into small enclosures. The greatest disadvantage of these cables is their higher cost, since special tools, techniques, and skills are required to manufacture them, but they are still very widely used in demanding environments. Another area where they are used is in test and measurement, primarily with vector network analyzers, as well as for interconnections within conformance test systems. This concludes our presentation, Understanding Semi-Rigid Cables. If you'd like to learn more about cables, cable measurements, network analyzers, or other test and measurement instruments from Rohde Schwarz, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.